In this section, which is A2, Unit 10, Lesson 2, we're going to look at some specific sequences and series. Now, the first lesson was just kind of general, and I know you might be feeling a little bit overwhelmed at this point because that first lesson is kind of broad and it's vague. But this is going to be much better because we're fixing to get specific and we're fixing to get more mathy with it, not all this what if. But anyway, we're going to look at the difference between arithmetic and geometric sequences and series. Now, if you're taking notes, you might want to get a different page, one for arithmetic and one for geometric. First of all, pronunciation of this word. If you look around, you will find everybody says it, multiple different ways. I pronounce it arithmetic. Some people say arithmetic, some people say arithmetic, so it's whatever you want to say, the arithmetic way. First of all, definitions. An arithmetic sequence has a constant difference between any two terms. So if you look at any two terms, you can add or subtract each pair and you'll get the same number. There's a difference, a common difference. This common difference is notation of D. When we get formulas, you're going to have a D in there, and that refers to a difference. If you add or subtract the two terms, you get the same number. Alright? A geometric sequence has a constant ratio. Now we get the ratio by multiplying or dividing the two terms. Arithmetic, we're going to add or subtract. Geometric, we're going to multiply or divide. Now this ratio could be a whole number. For example, your ratio could be 2 over 1. Doesn't have to just be a fraction. The symbol for the common ratio is going to be an R. So we're going to have two different sets of formulas. One for arithmetic, one for geometric. Your arithmetics will have a D. Your geometrics will have an R. So first, let's look at just arithmetic. Let's look at these three examples, and we're just going to look at the sequence and we're going to determine, is it arithmetic, yes or no? And if yes, what's the common difference, or D? Our first one, 5, 8, 11, 14, 17, well, we need to find the difference between these two numbers by subtracting. So the difference from here to here is 3. From 8 to 11 is 3. From 11 to 14 is 3. 14 to 17 is also 3. So we have the same difference all the way down. So this is a yes. Now what is that common difference? Well, D is equal to 3. Alright, let's look at this one. What is the difference between 23 and 16? And 16 and 9? Well, 23 minus 16, and since these go down, we are going to use a negative number, so that's going to be minus 7. From 16 to 9, you went minus 7. From 9 to 2, minus 7. From 2 to negative 5, minus 7. Since the differences are all the same, we're going to answer yes. Now what's our common difference? Our D for this one is negative 7. Okay, let's look at this third one. The difference from here to here is plus 1. The difference from here to here is plus 1. From here to here is plus 2. Here to here is plus 3. We have different numbers, so our answer is going to be no, and we're not going to have a common difference. So now let's get a formula. This is the formula for the arithmetic sequence, and the formula is A of n is equal to D times n minus 1 plus A1. Alright, let's think about what all's in this term. N, A to the n, is going to be the term that you are looking for. If I'm looking for the 23rd term, this is 23. D is the common difference. So after you've looked at your sequence and you've figured out what the difference is between the numbers you have, that's going to be your D. Alright, n minus 1. Well, if I'm looking for the 23rd term, my n minus 1 is going to be 22. So that's going to change. It's going to be one less than whatever term I'm looking for. Then this last term here, A1, that's going to be the first term in your sequence. No matter what, no matter which term you're looking for, you're going to perform this operation that will vary but you are always going to add the first term back. So let's look at an example. So this first example, we have the sequence -5, -1, 3, and 7, and we want to find the 24th term. The first thing we need to do is write the rule for this specific sequence, and we're going to use this formula to do it. Now the first thing I'm going to need is the D. So what is the difference from term to term here? Well, from 5 to -1 is +4. From -1 to 3 is +4. From 3 to 7 is +4. So my D for this is 4. Now if I write that in formula form, any A to the N I'm looking for is going to be 4 times, all right, N minus 1, because I don't know which term I'm looking for yet. The last thing, A1 is always going to be that -5. And if you want to change plus a negative to minus, you can. Now we have a specific formula based on the general formula for this sequence. So let's find the 24th term. All right, A to the 24 is equal to 4 times. All right, N minus 1 is 23. Then I've got -5. So now we're going to do the math and we'll come up with our term. 4 times 23 is 92. And 92 minus 5 is 87. So the 24th term in this sequence is the number 87. Now do you see how much easier arithmetics are going to be? Because you can skip to anywhere you want to. So would this be a recursive or would this be an explicit? It is explicit because we don't have to find all the terms in between. Let's try another one. Here we have the sequence -6, -9, 12, 15, unknown, and we want to find the 38th term. So first let's write a rule just for this sequence, and it's going to start with A to the N. I'm going to leave it in. Alright, now I need for D, I need the difference between each one of these terms. From 6 to 9 was a -3. From 9 to -12, -3. 12 to 15, -3. So my difference is -3. N minus 1, since I'm still writing a formula, I'm not putting the term numbers in yet. I just want this to be a formula for any term. Plus, but since A1 in my general rule is always the same, I'm going to have -6, and I'll just put -6. Now, if you want to go ahead and distribute this now, you can, but it'll actually be easier if you leave it in this form, because you can just subtract 1 real quick and then multiply by 3. So let's go with A38. I'm going to have -3 times. Alright, I'm going to put 38 in here. What's 38 minus 1? 37 minus 6. So now -3 times 37 is -111. Minus 6 is -117. Now let's look at an arithmetic series. Remember, your series is just when you take a sequence and you add all the terms together. So here's our formula. Notice the formula we just used for a sequence said AN. This one is notated by SN, so that's how you know the difference. If you have AN, you're just looking for a certain term. If you have SN, you're looking for the sum of the terms. N naturally is going to represent the terms that you're asked for. If they want you to sum the first 10 terms, then this is 10. Alright, A1 is going to be the first number in the sequence. AN is going to be that last number that you're trying to summate divided by 2. So, let's look at an example because this gets a little bit interesting. If we have 2, 4, 6, 8, 10, and it goes on and on and on, we want to find the sum of the first 10 terms in this sequence. So let's get our formula and let's start filling in. I'm going to find S10. Alright, so 10 is going to be my N. Now, I'm going to add A1, which is 2, plus All right, what do I need in my formula there? I need AN, A10, in other words. So do I have the 10th term? No, I don't. I have 1, 2, 3, 4, 5. I need to find the 10th term. Now, do I have to extend it on out? No, even though this sample would be relatively easy, let's go ahead and look at the process. What I need for my formula right here is I need A to the N. How can I get that? By using the formula we just used. So you're going to get a lot of practice. So let's do A10 is equal to, first I need D. Come back over here. What was the difference between each one of your terms? 2 times N minus 1 is going to be 10 minus 1. Plus A1 is the first number here, 2. So now I have 2 times 9 plus 2, 18 plus 2 is 20. So my A to the N term up here is 20. And I'm going to divide that by 2. And there it is. That was probably the hardest part of applying the formula. So now you have 10 times. All right, 2 plus 20 is 22 over 2, which is 11. And 10 times 11 is 110. So the 10th term, or the sum of the first 10 terms of this series, is 110. Let's try another one. This next problem is written in a different format, so we're going to have to do a little critical thinking about what we know and what we need. But we're asked to summate the numbers from 1 to 12 for the expression 6x minus 4. And we want to use our arithmetic series formula to do that. So I know that when I get ready to use this formula, I'm going to need the first term and the nth term in my sequence. So let's go ahead and find those out. How can I find the first term in this series? Well, I can plug in the first number, 1, into this expression. So A1 is going to be 6 times whatever my starting number is, minus 4. 6 times 1 is 6, and 6 minus 4 is 2. So my A1 is 2. Let's just go ahead and get the formula started down here. I am going from S to 12. S12 equals, all right, my N is the total number that I'm going to sum. So that's 12 times. My A1 now is 2. All right, I'm going to need to add my N number. So I'm looking for the 12th one. I'm going to do the same thing, just with 12. So A12 is equal to 6 times 12 minus 4. 6 times 12 is 72, minus 4 is 68. So now I have 68 over 2. So, you see, we had to think outside the box a little bit, had to find a little more information, but we pulled it off. So now I've got 12 times 2 plus 68 is 70 over 2, which is 12 times 35, which is 420. So the sum of the first 12 numbers in the arithmetic series is 420. If you added them all up together, you'd get 420. Now, wasn't that easier than substituting all the numbers 1 through 12 into here and then having to add them up? Because that's what we did in the last section. So you see, the formula is going to save you some time. Next example, I want to find the 6th term of the sequence 130, 65, 32.5, 16.25. So I need my A1. I'm looking at this formula up here. Remember, we're trying to find the term in a sequence. So A to the N, I need A6. My first term is 130. I'm good there. I need R. So how do you find R? Put the second term over the first one. Just remember that. R is the second term, which is 65, over 130. Now we can reduce this down to 1/2. Alright? Now let's plug it into our formula. I'm looking for the 6th term. My first term is 130 times r, which is 1/2, and I'm going to raise this to the n minus 1 power. So I'm going to raise this to the 5th power. So now I have 130 times. 1 to the 5th power is just 1, and 2 to the 5th power is 32. So when I multiply 130 times 1 over 32, I get 65/16. It's just that easy. And since our sequence is going into decimals, I'll go ahead and change this to a decimal, and that would be 4.0625. Okay. Now let's look at some series problems. So let's look at one more problem. I want to find sum of 14 terms from the sequence 4, 20, 100, 500. All right, how do you know which formula to use? Well, remember, the formula that has A is for a sequence number, for one particular term in that sequence. S gives you the sum of however many terms. So we're looking for a sum. Our N is 14. All right, we know our A1, our first term, is 4. The problem we're going to have right off the bat is we don't have an R. So how do you find R? The same way as you did with your sequence. Take the second term and put it over the first one. So my R here is 20 over 4, which is 5. So let's fill in and see. They want me to summate 14. A1 is 4 times 1 minus my R, which was 5. All right, my N again comes back over here to 14 over 1 minus 5. Okay? Now, let's do the math on this one. It's not going to be fun, but we have a calculator. So, 4 times. All right, 5 to the 14th power is a really long number. 1 minus 6, 1, 0, 3, 5, 1, 5, 6, 2, 5. This is when I really miss having a live class because they tell me these numbers. 1 minus 5 is negative 4. Okay, we need to simplify this. Right off the bat, I can tell you what I'm fixing to do. These 4's will cancel, and all I have left is the negative. So that's going to be a negative. I'll bring it to the outside. All right, negative of 1 minus all this number is going to be negative 610351562 It's just going to be one less than this. Now, negative times negative is positive. So that number right there, positive 610351562 is the 14th term in the sequence that we have here. Okay, our next problem is formatted with our sigma notation. So let's see what we would have to do to adapt it to fit in our formula. We want to find the sum of the numbers from 1 to 25 when inserted into this expression. So let's get our formula here. My S to the N is going to be 25. So my N is 25. Now, the first thing I need is the first term in the sequence. How do you find that? Well, you can plug in 1 for N. So 2 to the 1 minus 1 is 2 to the 0, which is 1. Alright, 1 minus. Now I need my ratio. Well, if my first term was 1, if I had my second term, I could put the second one over the first and get a ratio. So how can I find the second term? Well, you take the number 2 and you plug it into here. So if I do 2 to the n minus 1, that would be 2 to the 2 minus 1, which is 2 to the first. So that's 2. Alright, now my n is 25. Down here, I've got 1 minus 2. Okay, so my first calculator problem here is going to be to find 2 to the 25th power. So 225 is 335. 544, 32. All over 1 minus 2 is negative 1. So these two are going to be insignificant other than the negative number. When I do 1 minus this number, I'm going to get negative 3355443 1. It just goes down 1. And then I have a negative on the bottom, negative 1, which cancels out. So the term I need is 33554431. Now we're going to talk about one last concept here, and that is the concept of infinite geometric series. The series that we just got through doing, they were not infinite, they were partial sums. We were doing a certain set of numbers. We were summating a certain group of numbers. So what if you're asked to do a sum of an infinite series? Well, there's two different types of infinite series, the convergent and the divergent. And the way you tell the difference is you find your R. Notice these both end with the ellipses. And we're not told to find a certain group of terms. We're just told to summate the whole thing. Well, if you find your R by putting your second term over your first and simplifying, if the absolute value of that ratio is less than 1, then you have a convergent. If the absolute value of R is greater than 1, then you have what we call a divergent. If your series is divergent, then the sum of it is infinity. And it's not really infinity. You see this symbol here? We don't have Sn is equal to anything. We have the approaching symbol. So this says the sum of n approaches infinity. It's never going to get anywhere because the series doesn't end. So it just keeps on getting bigger and bigger and bigger. Alright? Convergent, we put that as S of n approaches some number. Now this particular one happens to be 1. So this series, if we add it together, if you added these numbers and just kept adding, and the series progresses by 1/2, that's your R. If you kept adding those terms together, it's going to get closer and closer and closer to 1, but you're never quite going to get 1. So that's why we say it approaches. Now we do have a formula. If you check it by finding your R and you have a convergent series, then you can use this formula. And it's just like the others. The terms are all the same. A1 is going to be the first term in your series, 1 over 1 minus your R. And you find that by putting the second term over the first. So it's not that difficult. This is not a really much used. We don't use this too often in Algebra 1, but I did want you to make you aware of it. And you do need to be familiar with the terminology and the fact that if R is less than 1, you have convergent. If it's greater than 1, you have divergent. Okay? And that wraps up this lesson. So go ahead and start working on some of those practice problems that you have. Let me know if there's any specific practice problems you need me to work. And I'll move on into the next lesson. See you there. Bye.